Hello, I'm JW. This time I'm going to have a look at relays. Now, we've had a look at relays in a previous video. That's basically a deal where you can apply power to one side of it and then it activates a switch inside via an electromagnet. So, seen those previously, but this time we're going to have a look at this particular relay, which, as you can see there, has some additional things on the front, because this does a lot more than just turn things on and off. So let's have a look at this, how it actually works with the instructions, and then we'll also power it up, see how it actually works in reality. Now, this is a fairly small item. It mounts onto a rail, such as something like that. And like most relays, it has terminals at the top here for the what would be the coil connections at A1 and A2. Normally on a relay, that's where you connect power to the coil. This is a 230 volt AC version in this case, so it's line and neutral. This one also has this additional S pin here, which is basically a signal input, and that's used to activate various of its features. And at the bottom here we've got three terminals, which is the switched contact. This is just a common and a normally open and normally closed, so basically a changeover contact when the thing is energized, so you could wire it up either way round, and just the holes in the bottom for that to go in. So in that regard, it's pretty standard, similar to any other relay. And in fact, if you just connected 230 volts to the A1 and A2 and connected some load appropriately to the switch terminals here, it can be used just as a normal relay. So when power is on here, this switch contact is activated, and then you take power away and of course it is deactivated. But of course you wouldn't be buying this for just that kind of function. And if you look on the side of this, you can see it has a whole load of different options and features on there. Also has a little diagram of the contact arrangements. Now if we have a look on the front of this, we've got these three adjustments and a couple of LEDs, one of which signals that there is power applied to the device, and the other one indicates that the thing is actually active and doing something. Now these are sold under various labels and different brands, and you can get them from various different suppliers. This one is branded up Geya or Geya or whatever it's called, but so they can have different ones. They're all basically the same. Now on the front here, these three dials, we've got two at the top here which are for timing. This top one is sort of your crude timing, so it goes from 1 second, 10 seconds, a minute, 10 minutes and so on, all the way around to 10 days. And then the one underneath is a percentage from 10 to 100%, and this is essentially a percentage of what you set here. So if you set 10 minutes, then this one will go basically from 1 to 10 minutes. So 50 would be 5 minutes, 90 is 9 minutes, and so on. And of course, if you took the 10-day option, then each one of these is effectively 1 day. So it could be 4 days or 5 days, whatever you would want. And it also goes down to 1 second, in which case this is then tenths of a second. So basically these two together just set the appropriate time that you want for your particular application. And then this one at the bottom, labelled A through to J, you just turn that to the appropriate one you want, and that selects the function that it's actually going to do when either power is applied or when you've got power applied and then you're adding an extra signal into the S terminal here. And this is a 230 volt relay, so by signal what we mean is that line is connected to A1, neutral is connected to A2, and then to activate it or provide the signal, you're just basically connecting line to the S terminal, so it's just basically a link between those. So 230 volt AC goes in there, and then it will start doing whatever you've selected it to do. As with all relays, the terminals here at the bottom are totally separate from the input, so you could use those to switch whatever you wanted. No voltage connected to these, also called volt-free in some cases, just means it's a set of switches with no connection to anything else. So you could just connect your voltage into the common, whatever you want, 230 volts, 12 volts or whatever else, and then it will just switch on the output on the other terminal. And we'll set this up in a minute and get something connected to it. Now in terms of the functions, there's a whole list of them on the side here from A to J, but this is not particularly helpful just to have a look at. So what we'll do is set this up with some indicators, and then we'll just demonstrate these various functions and also some examples of what you might want to use those for. And of course naturally it does come with the instruction sheet, which basically outlines the various specifications, and on the back all of the various timing functions and features that it has got. Now I've got the relay wired up here, just put on this rail. Now normally if you're going to use one of these you would need to put it into an enclosure, so obviously the wires and terminals are not exposed, but this is just a demonstration, so obviously it's just sitting there. And I got these three things here. This one just turns on the power to the relay, and that's going to be those A1, A2 terminals on the top there. Just basically the switched line going in, neutral permanently connected. And this red indicator here will illuminate when the power to the relay is turned on. And we'll also see that the green LED here on the relay itself will light up when it's powered as well. This one is connected to the trigger input, so we've got it just between the two terminals there, the A1 and the S terminal at the top there. And when that's on, it will just connect those two together for as long as we hold the button down. And then finally these two indicators here connected to our output. So we've just got the line coming into the common terminal, and then the line out, which is the switched one, just goes to the indicators in this box. They also have a neutral, of course, which goes back to the supply. Now there's two here, but they're both connected in parallel, so when these are on, the relay contact is energized, and when they're off, of course, it is not. Now I've set the timing here to approximately 5 seconds because we don't want to be waiting for 2 days for something to happen, because of course that would be nonsense. And we're just going to go through some of the options here on the adjustment. Now I've set this to A, which is an on delay. In this case we're not using the trigger switch, so we're just going to leave that off, so it's just going to be a question of turning on the power and seeing what happens to the switched output. And what should happen, as the name suggests, an on delay, is that when you turn on the relay or power is applied, the contacts do not energise straight away. They will actually energise after an appropriate delay, so in this case that should be about 5 seconds. So if we turn on the power here, you see the red indicator's on, and we see the green's on, and the red one is flashing, and there we have our output being switched on, and so that was approximately 5 seconds. And we now see that the red is on solid, which indicates that the output is actually switched. Basically when it flashes it means it's in the timing mode. And if we switch off, of course, they both go off, and that is of course repeatable. So we turn on, these are not on yet, but there is a bit of a delay, and then of course once the delay is finished, yep, the output is switched on. Now we just adjust this to B, and this is a sort of a click round type of adjustment, so not any problem there. The top one also clicks around to those options, but this middle one is just a continuously variable, so although we've got it set to 50%, it's not going to necessarily be exactly half, it's just a general guide as to the ratio of what the top one is. Now B is described as an interval timer, which basically occurs when the power is on. So in this particular case, when you turn it on, the contacts are energized straight away, but they only stay energized for the time you've set, even though the power obviously can remain on afterwards. And again, the trigger input is not used. So if we turn on, we should see these come on straight away, but then they should go off after approximately 5 seconds. So switching on, and there's our output being switched on, and then we see it's now turned off, even though the relay is still energized and the light is still on. Of course our outlet has only just run for the 5 seconds that we set. Now C on this one is a repeat cycle, and there's two of these, one of which starts in the off position and the other one starts in the on position. And essentially what will happen is that once power is applied, it will cycle between the output being on for 5 seconds and then off for 5 seconds and then on and so on, and repeat endlessly. And of course you could set any time you wanted. Trigger input is not used in this case. So C is where it starts off, so if we turn on, these will be off, they'll turn on after 5 seconds and then continue to cycle on and off. So there we go, and after 5 seconds or so, yep, the output will turn on. And again we see the lights flashing because it's still timing in this case, and now it's gone off, and it's still flashing away there, but basically this is the on flash, so it's on most of the time flashing when it's on, and it's off with just a reflash in the off state. And that will just repeat endlessly until bored. And then the next one is essentially the same thing again. The difference with this one is it starts in the on condition, so as soon as we turn this on, it will activate the output. There it is, flashing away there, and after 5 seconds this will turn off. And then after another 5 seconds, of course, it turns back on, and again this will repeat basically forever, or until we turn off the power. Now none of those actually use the trigger switch in that case, so those are just a question of connecting power up, output does whatever you've selected on the front. So let's just move on to the next one. Now E on the settings is an off delay, so if we apply the power, nothing actually happens, the light's on but no timing going on. If we apply the signal to the S connection, then the output switches on immediately, and for as long as the signal's there, that will just remain on for the whole time, so you could leave it on permanently. However, when you remove the signal, notice the output stays on, and now the timer is obviously running, and after that 5 seconds delay, then the output will switch off. And that is repeatable, so if we just provide the signal in again, there it is. Remove that, 5 seconds delay has started, and then it will switch off after that. And you can have multiple inputs there, so if it's on and then you switch it off, if you then put it on again, it will actually reset the timer, and again it will stay on basically until the signal has been gone for the 5 seconds or whatever time you've set. Now F is described as single shot, which basically means that when you turn it on, and again nothing happens, and again we're using this trigger input, just connecting the input signal to that S terminal, and again we've got the 5 seconds set, so when we turn this on, basically they will turn on for the time delay, which is 5 seconds, and then at the end of the time delay they will just switch off, and that's it. It will never do anything else. It's now just in a sort of stuck state. The only way to stop that is to remove the signal input, and then if we try again, we can have another 5 seconds of operation, and again after the 5 seconds has elapsed, then it will switch off. Now G is very similar, so again if we switch on, nothing happens, but this actually works when the signal input is taken away, as in it's turned off, and then you get your 5 seconds delay and so on. So it's essentially the same thing as previously, except that rather relying on the signal being apparent and then it does its options, if we turn the signal on, nothing happens, but it's the removal of the signal input which triggers the timing delay, and then obviously it goes for the 5 seconds or whatever you've set. So one is basically applying power, the time runs, this one is removing the power signal, and that's when it runs. So it's off there, it's on, nothing happens, turn it off, and then the thing is triggered for the time delay we've set. Now H kind of combines two timing functions, so if we switch on, again nothing happens, just lights up on the indicator, no output present. If we turn the signal input on, then nothing happens for a while, but after the 5 seconds has elapsed or whatever you've set, then the output of course will turn on, and this will basically stay on for as long as the input signal is present. And then when you remove the input signal, you also get the delay as it turns off, so again the 5 seconds here, and then after that it will just switch off, and you can of course repeat that by turning it on, but remember there's a delay because on delay as well, so 5 seconds and there it is, stays on as long as you want, switch it off, and then after 5 seconds the output will be removed. And I is power is on, nothing happens, triggered in the off position and the output's off. If we apply the trigger input, then the output switches on immediately. This does not actually use the timing function at all, it is purely a case of once you've selected I, the timing part is ignored. If we switch off, then it still stays on, so nothing giving there, but if we turn it on again or provide another signal to it, that is what turns it off. So this is what we might call a latching relay. So in other words, it just changes state every time a signal is put in. So switching it on, we can leave it on as long as we want, and then to turn it off again we have to provide another signal in, and it will switch off immediately. And then finally J, which is the last one on this, this is a pulse generator. So again we switch on, it just sits there, and we see the lights there, and then it will turn on for a brief period and just basically click off straight away. Doesn't use the trigger switch in this particular case, and once it's done that, that's basically it. So if you want to redo it, you have to actually remove the power, apply power again, 5 seconds delay or whatever you've set on the front there, and then it just gives you a ½ second pulse on and then off straight away. And you can say repeat that as often as you want. So flashing away there, there's a ½ second on pulse, and then it clicks off, and then that's it. Now what could these things be used for in reality? Well, with regards to that of course is many things, and it all depends on what you're wanting to do, but some examples here. The option E here, which is the off delay, that could be used for things like lighting in a communal stairway. What you would have is a push button, not one that can be latched down normally, just one that's just press and then release. So you connect your lighting to the output, set it to an appropriate time, like say 1 or 2 minutes or something. It would be powered continuously, and then you have a button on each floor or outside each apartment or whatever, So if people want to turn on the hallway lighting, they will just press the button, the lights stay on for the predefined time, and then after the predefined time they will switch off. And that's why you wouldn't have a switch that can be switched to both positions. You want like just a press button that would click on and off, and then if someone upstairs presses it again, it basically adds the time back on again. And of course that would avoid people turning lights on and leaving them on permanently. And the other thing you could use this for is, say, with a central heating system, if you had an old boiler that did not have a pump overrun, and most modern boilers have that built in, but of course there are some which do not. So what you do there is you would connect up the boiler, of course, in the usual way. So when the boiler's on, the pump usually runs. But if the boiler doesn't have that feature, what happens then is when the boiler goes off, the pump is turned off immediately, which could result in a big slug of basically boiled water in the boiler itself. So what you could do is to connect the pump via one of these, so that when the heating is on and the boiler's on, pump comes on straight away and it's running and doing all of what it does. But then when the boiler is switched off, the pump continues running on for, say, a minute or two, and then after the water has been circulated through, that will just switch off and go back to its off state. Now C and D, which is the repeating one, could be used to operate, say, a warning lamp or something. You've had, say, electric gates or something, which should have a warning lamp to indicate that they're opening or closing. Again, some boards have this feature built in, but others don't, so you could have this so that when the motors are energised, the relay is also energised, connect up a warning beacon or something on the outside, and then it will then just switch on and off in a kind of flashing fashion, in this case at 5-second intervals, although of course in reality you'd probably want it to go somewhat quicker than that. So if we say went to 1 second, that's probably going to be a bit more sensible, and I see it will just flash the warning lights on and off for the whole time that it's powered, and then of course when the motor is not powered, the warning beacon switches off. And I, which is the latching one, can use that for lighting as well. So you have the same sort of push button, as in you can just press it. In some cases you may want that so it's just push on and push off. So in that case, press it, the lights come on, press it again, the lights go off. Now I've done a few installations like that, and that's generally easier, so that then you can turn things on and off in whatever sequence, and you don't have to remember to leave switches up or down or whatever. It also means you can turn them on and off from any position. So rather than running miles and miles of cable and having two-way and intermediate switches and all of that malarkey, just have a press button, so it's press on, press off. You can then have literally as many of those as you want, like 5 or 10 even if you wanted. Just a 2-core and earth cable to each switch, and then wherever you are in that particular building, if it's a large sort of events hall or something, one press turns the lights on and another press turns it off, and that can be from any point. Turn it on in one place, turn it off somewhere else, doesn't actually matter, and so avoid all that malarkey of having dozens of intermediate switches all over the place, all of which will end up in different positions, and of course it could be confusing. And things like J, which is a pulse generator, that will be used normally where you want to provide a signal to some other system from something which is either not designed to work with it or is in some way incompatible. Things like door entry systems and say gate opening things and door opening stuff, so that most of those just require a quick pulse on the input or some on the control board to either open the gate, close the gate, open the door, or do whatever else. But of course you may have some other system which is designed to open that gate which doesn't have any particular compatibility with it, or it's running a different voltage or something like that. So then in this case you'd stick one of these in on the pulse there. The pulse output would go to the, say, gate control board or something like that, and then when the thing itself was activated you just get the pulse output. There it is, and then that will have opened the gate or closed it or done whatever. And of course the time delay is useful because in certain one I did do, there was 2 competing systems basically, and if there wasn't a delay, one of them would have basically overridden the other, and it would have been stuck in a continuous loop forever, and the door would have never opened, or it would have stayed open forever as well. So again, quite a useful thing there. Really designed, I mean ideally it's obviously good to have the same equipment for everything, but there are circumstances where extra parts are fitted in at a later date from different manufacturers, and therefore it's necessary to make sure these things do actually work together and are compatible. And of course, being a relay, this output is totally separate from the inputs, so whatever's going on there is electrically not connected to any other part of the system, so you can have one completely separate system there connecting to something else here. 230 volts here in this case when it's on, but obviously that could be 12 volts, 24 volts, or pretty much whatever you want. So look there at a timer relay, a multifunction one in this case. So you can get these in a variety of styles, sizes and types. This has a whole range of function on, some only have one, and again the range of functions may vary depending on who makes it, but quite useful things. They're not massively expensive, so worthwhile having a look into these, even if you're not going to use one straight away. Useful to know that they exist, because you may find an application where this is exactly what you need. So that is it for this video. Until next time, thanks for watching.